Unit 5, Learning Target number 5. Use proportions to solve unit rate problems. In the last lesson, we talked about writing unit rates and understanding what they are. In this lesson, we're going to talk about how to calculate unit rates. What happens if we're given a rate that isn't a unit rate, but we want to make it a unit rate? And that's what we're going to deal with today. So we're going to start with our friend Fido. Fido is a little puppy driving a car. Silly puppy, you can't drive a car. You're not old enough. And you don't have hands. What's more disturbing to me is the fact that this car is moving, which implies that both of these cars are moving and the dog is actually driving the car. That scares me a little bit. But moving on. If Fido drove 60 miles in 2 hours, how many miles did he drive in 1 hour? Now, can you find a ratio or a rate in this problem? Well, yes, we can. We see that there are 60 miles. Fido drives 60 miles in 2 hours. 60 miles in 2 hours. Our question is, how many miles did he drive in 1 hour? So we want to know, we know that he drives 60 miles in 2 hours. We want to know how many miles he drives in 1 hour, and we don't know that answer right there. So we know we have X number of miles. Now, how can we find that? Well, if we look at this, we see that these are just like any other set of fractions or ratios that are put together. 2 divided by 2 gives me 1. If I want to get 1 hour, then I divide the bottom by 2. So I'm just simplifying this ratio, this rate. So that means that I'll divide the top by 2 as well. And that will give me, instead of X miles, I'll get 30 miles for every 1 hour. If I want to solve a problem like this, all I have to do is simplify the rate or the ratio that I see. Now, we can do this quickly if you want to think about it. The easiest way to do it probably is to write the ratio with the unit that you want on top. We want to know how many miles he drove. So we're going to put that unit on top, 60 miles. And then we're going to divide by the number that was on the bottom. So we put the number on the bottom there, and we divide the 2. Well, 60 divided by 2, 2 goes into 6 3 times. 2 times 3 is 6. We subtract. 6 minus 6 is 0. That leaves us with 0 on the bottom. 2 goes into 0 0 times. 0 times 2 is 0. 0 minus 0 is 0. That's a lot of zeros. So our answer is 30. How many miles did he drive? He drove 30 miles in 1 hour. And we got the same thing up here, 30 miles in 1 hour. Before we go, I want to call your attention back to this part right here where we had 60 miles in 2 hours, and we put that equal to 30 miles in 1 hour. I want you to look at this because we're going to be talking about this much more throughout the rest of this unit. What we just saw on the last slide is what's called a proportion. A proportion, you may have heard people say something about things being proportional, being similar to each other. Proportional just means that they are two ratios that are equal. A proportion says that two ratios are equal. So in this case, is 2/3 equal to 4/6? Are they proportional? Is this a proportion? Well, yes, because 2 times 2 is 4. And 3 times 2 is 6. These two ratios are equivalent. And two equivalent ratios that are set equal to each other are called a proportion. Proportions are extremely useful. Proportions, I even like to call them magical because you can use them to solve so many problems. Sometimes it seems like it's just magic that you're doing. Now, we're going to use proportions to find missing values in equivalent ratios and rates. So we're dealing with ratios and rates, and here is one ratio that we have is 4:7. And we know, based on this equal sign right here, that these two are equal to each other. But what we don't know is the value of the letter A. We don't know what A is. But because we know that these two proportions are equal to each other, we can find the answer. And we can do that one of two ways. We'll start off by doing it the way that probably makes sense to you right now. How do we get from 7 to 42? Well, we multiply by 6. That means if we multiply on the bottom, then we have to multiply by the top. Since they are equal, we're going to create an equivalent ratio, so we'll multiply by 6 on the top, and we're going to get 24. So our answer should be 4/7 is equal to 24 over 42, because both of those are multiplied by the same number. They are equivalent. Now, there is another way to solve this kind of problem, and that is what we call cross-multiplying. And we use our equations that we learned in a previous unit to solve this. So let's take a look at this proportion again, and we'll look at it using this new way to solve it. 4/7 is equal to A over 42. Now, the first thing we're going to do is what we call cross-multiplying. And cross-multiplying is just when we multiply diagonally. So the first thing we're going to do is we're going to multiply 7 times 8. 7 times A is equal to what? Well, we don't know what A is, so we're just going to say 7A is the answer. 7 times A is 7A. Now, then we'll multiply 42 times 4. You can work that out if you like to, but 42 times 4 is, 4 times 2 is 8, and 4 times 4 is 16. So we get 7A is equal to 168. Now, this is a simple equation. We have done these in the past many times. So how can we solve this equation? Well, the first step is to get x all by itself, and we do that by doing inverse operations. Here we are multiplying 7 and A, so we're going to use the inverse of multiplication, which is division. We're going to divide 7 by itself. 7 divided by 7 is 1, and that leaves us with A. Now, the third rule is that we have to, whatever we do to the left side, we have to do to the right side. So on this side, we're going to divide 168 by 7. And we can work that out off to the side here. 168 divided by 7 plus, you're allowed to use calculators at this point if you like, so you can pull out your calculator. 7 goes into 16 2 times. That leaves us with 2 times 7 is 14. 16 minus 14 is 2, and 8, 28. 7 goes into 28 4 times. So our answer is, subtract those by the way, and you get 0. A is equal to 24. Now if you notice, A is equal to 24 down here, and up here, A was equal to 24. We got the same answer. Let's revisit Fido again here. Isn't he cute right there? We're going to revisit Fido, and we're going to solve this problem using a proportion instead of just using a unit rate. We're going to use a proportion here. So the first thing we know, Fido drove 60 miles in 2 hours. That's our first ratio. Again, we've got it right there. 60 miles in 2 hours. 60 miles, 2 hours. Now, what is that equal to? Well, we know that we need to write our proportion. Now, we're going to want to match our units across the equal sign. So we'll want to have miles on top and hours on the bottom. We want them to match. So, how many miles did he drive in 1 hour? Well, we don't know, so we're going to put a little variable here for H for the number of, we'll see, P for puppy. P for puppy there. And then we'll do our next step, which is what we did before, which is cross multiplying. 2 times P is 2P. 60 times 1 is 60. And when we solve our equation, get x by itself, using inverse operations, we divide on this side, which means we divide on that side. That gives us P is equal to 60 divided by 2, which is 30. And how many miles can Fido drive in 1 hour? He can drive P miles, and P miles is 30 miles. That's a lot of mileage for a puppy. Okay, here is our last ratio rate problem. At Bob's Donut Shop, which any donut shop is usually amazing, at Bob's Donut Shop, you can get 3 mini donuts. 3 mini donuts per dollar. 3 mini donuts per dollar. How much will it cost for a dozen donuts? So there's a couple of words here we need to understand. First of all, we need to know what per means. Per means the same as for every. So per means for every. And anytime you see that word, anytime you see the word per, you know that you're dealing with a rate, just like you do if you see for every. At Bob's Donut Shop, you get 3 mini donuts per dollar. So we know immediately we're dealing with a rate, and we're going to write it out like this. 3 doughnuts, we'll put DO there, per dollar, per $1, right? So we won't use DO there, we'll use $sign there. So 3 doughnuts for $1. Now our question asks us, how much will it cost for a dozen donuts? What does a dozen mean? A dozen is 12, right? If you ever bought donuts, you probably bought them by the dozen, and they're amazing. So now I have written this in a strange way. I have 3 dozen donuts, rather 3 donuts for $1 right here, but I put 12 on the bottom. Is that right? How much will it cost for a dozen donuts? 12 DO. That doesn't make sense because I didn't match my units across the top and across the bottom. I've got to get rid of that. I've got to get rid of that and put that up on the top. 12 donuts for how many dollars? For how many dollars here? That is my ratio, my proportion. Now I need to solve it. We've got our proportion. Now we need to solve it. We'll cross multiply first. That's our second step here. Cross multiply. So we'll do 3 times x, and that is 3x. And we'll do 1 times 12. And 1 times 12, of course, is 12. And then we'll solve, get x by itself. Use inverse operations. 3 divided by 3 is 1, and 1 times x is just x. On this side, 12, we do whatever we do to the left side, we do to the right. 12 divided by 3 is 4. X is equal to 4. So, how much will it cost for a dozen donuts? Well, according to our proportion, it should cost $4. $4.